A lot of what we're going to talk about with the stat stuff is like with special cases and events. So anytime we talk about a specific event, an experiment or kind of the scenario or the situation, a lot of what we're going to do is hopefully things that you know, but believe it or not, there are a lot of things that students don't know. How big of a sample space that whenever we talk about certain things that we're dealing with. Okay? Obviously, tossing a coin, there's two sides to a coin. There's the heads and the tails. Rolling a dice. Okay? If it is a normal die, okay, just one single die, there are 6 sides. Now, obviously, there can be other die that have more than 6 sides, but normally it's going to be 1 through 6. Okay. Then we get into, if we toss 2 coins, then the sample space, you can have a heads and a heads and a tails and a heads, or 2 tails. Okay, depending on what you have. The big one is usually with students is whenever we talk about drawing a card, okay, on a standard 52 card deck. Okay, we're not talking about jokers, we're not talking about wild cards, things like that, but a standard deck of cards. Okay, there are 52 outcomes. Okay, there are 4 cards. Okay, half of the deck, if you don't know, half of the deck is black, half of the deck is red. A fourth of the deck are hearts, a fourth of the deck are diamonds. Then you have spades and clubs, okay, that are the black cards. Okay, believe it or not, for whatever reason, I don't know if kids just don't play cards anymore or what, but that is one thing that is, for whatever reason, students have a hard time with. It goes from, depending on how you look at it, either ace, 2, 3, all the way up to king, or 2, 3, 4, all the way up to ace. As far as whenever it talks about face cards, they literally have faces on them. Okay, Jack, Queen, King. An ace is not considered a face card. Why? Because if I can find one right here in my hand, there is no face on it. Okay, so things that whenever it asks or gives you certain scenarios or situations or events, whatever you want to call it, it'll be specific as far as what you're looking for. Okay, there are 4 suits. Okay, that's your diamond, your heart, your club, your spade, so on and so forth. There's 13 of every single suit, giving you the 52 possibilities or the 52 cards. Now, if we give you jokers, which normally I will not do, okay, it'll tell you that. Okay, but for the most part, there will never be any jokers in your standard deck or whenever I give you a scenario or an event. So whenever, and then selecting a day of the week, 7 days a week. Hopefully you learned that in kindergarten or pre-K. So if not, today is Monday, just so that kills one of the 7 days, so you know that. Fundamental counting principle. Okay, it is if one event occurs m number of ways, okay, and another occurs in n number of ways, then the number of ways that both events can occur is m times n. All of you woke up this morning, first day back from spring break, and you put clothes on. You had to figure out what you were going to wear. You either walked into your closet or you looked on the floor and said, yep, that looks good, you put it on. Right? Pretty much. Okay? Regardless of whatever your closet or your clothing situation was, as far as you smelt it, what was clean, maybe not, maybe it was. Okay? You had choices that you had to make. Okay? Hopefully, whenever, so it says like, if you have 12 shirts, 7 pairs of pants, and 3 shoes, okay, how many different combinations of outfits can you possibly have? So, you're not going to put on, most likely, okay, if you're talking about shirts, if you just pick out one shirt. Now, obviously, you can put on a t-shirt and a sweatshirt. I get it. Okay? You have to put on a pair of pants. Hopefully, you're not putting on 3 pairs of pants. Okay? Or pairs of shoes, 2 feet, 2 shoes. Can't really put on more than that. Okay? So whenever you do this, if you're going to talk about the different types of combinations you can have, I'm not talking about, hey, this looks good with this. You know, I can't wear a blue shirt with pink pants. Okay, doesn't look good. Okay, but we're just talking about all the different possibilities that I have. So all I'm going to do is take these three numbers in this case, and I would take the 12 shirts, multiply it with the 7 pairs of pants that I have and the 3 pairs of shoes, and I would multiply all of those together. Okay? So then I can see how many different possibilities am I going to have. Okay? And essentially for everything that I have, 252? Okay? Possible combinations. Because every time I could have the same shirt, the same pair of pants, but I could have 3 different outfits just by changing my shoes. Does that make sense? Okay? Even though the shirt and the pants are what makes the outfit, the shoes have got to go. Okay? They're the finished product, right? Okay? Can't wear sandals today. It's 52 degrees outside. Okay? Can't wear my furry boots. It's too warm outside. Have to go with something a little basic, kind of middle of the road. Whatever. Okay? Because I have to have 3 pairs of shoes.
Yeah, but why don't you say like...
Well, that's why I went with these. I didn't wear my furry boots today. Okay? Heck no, I don't have furry boots. You all'd look funny at me if I did. More than you already do.
Yeah,
that's true.
That wouldn't surprise me.
So then... like in this case, it says, how many possible zip codes are there? Okay. Zip code right here in Liberty, 64068, right? So how many different places are there? How many different numbers are there? 64068. 5 spots, right? So I'm dealing with basically five spots in terms of 1, 2, 3, 4, 5. How many options? Every number, if I look at the whole thing, I have a single digit number, right? How many different options do I have right here? Huh? 9. You're close, but I still have... Why 10? Because I can still use 0, right? Okay. Well, no, that's on the next one. Not yet. Okay? Not yet. You're right, but not yet. So, in this case, I have 10 options. What about the next number? Can a number repeat itself? Yeah, so how many spots do I have every single blank or every single digit? 10. Okay? So, before I do anything, okay, the options are 10 to the 5th or 10 times 10 times 10, or essentially I have 100,000 different options. So all I'm going to do with this is I'm just going to take 10 times 10 times 10 5 times. Okay. Now, like Devin just said, now it says on the next one, it says how many possible zip codes are there if 0 can't be in the first digit. Doesn't say anything about every other digit after that, but the first digit can't be a 0. So then if I go back to each blank, what's the only value that's going to change? First one. How many options do I have? 9. So I'm just going to take 9 times 10 times 10 and do the same thing. So now I lost basically 10,000 spots and I'm down to 90,000 possibilities. Example 3 says if there are 5 students who can receive 5 different scholarships, how many different ways can the 5 scholarships be awarded? So now on one like this, how many can the first, so it gives you a certain stipulation. It says there are 5 students who can receive 5 different scholarships. How many different ways can the 5 scholarships be awarded? It doesn't give you any sort of specifics like it does in the next question. First person, 5 people, 5 scholarships. How many options or how many scholarships can that first person get? They can get 5. What about the next person? How many scholarship opportunities do they have? They still have 5. Okay? It doesn't say that, hey, you can only get 1. There could be 5 people. One person could get all 5 of these scholarships, and the other 4 are just out of luck. Okay? And they're not going to get anything. Same way for the third person. They have a crack at all 5. Fourth person, they have a crack at all 5. And the fifth person, they have a crack at all 5. So I would just take all of those and multiply them together. 5 to the 4th, or 5 to the 5th power, or 5 times 5, 5 times. So there are 3,125 different ways of going about this. Because it doesn't give me any sort of stipulation. It doesn't say, hey, little Johnny can only get 1, Sally can only get 1, okay? They have an option to get all 5. Every single one is available. Now, whereas the second one says, how many different ways can the scholarship be awarded if each student can only win 1 scholarship? Okay? So, if first person, okay, we still have 5 people, right? That hasn't changed. There's still 5 scholarships. First person up, how many options do they have? They have 5 options. What about the second person, though? 4. Okay? Why is it not 5 again? Right, because one of them's already accounted for. Okay? One of those is already accounted for, so there's only 4 options now here. What about the third person? How many options does that third person have? They have 3, and then 2, and then the last person is just going to get whatever's left. Okay? So I'm just going to take those 5 values, and I'm going to go 5, 4, 3, 2, 1, and multiply everything together. And it goes from being 3,125 to 120 possibilities. Now, the next part then deals with what's called factorial definition. Okay, anytime you see n or a number with an exclamation point, it's not like we're in English class and we're saying 4! Okay? It's 4 factorial, or it's 10 factorial. That just means we're starting with that number, and then we're counting down all the way until we get to 1. Why don't we ever want to get down to 0? Why don't we go 4, 3, 2, 1, and 0 and multiply all those together? It'll always be 0. Okay? You're always going to stop at 1 regardless of wherever you're at. So 4, 3, 2, 1. Now, in certain situations, you probably don't want it. 4, 3, 2, 1 is probably not too bad, and it's just going to be 24. 4 times 3 is 12. 12 times 2 is 24. We're good. But one like 10 factorial, we probably don't want to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Probably don't want to multiply all those together. Okay, you can. That's fine. But there is an easier way. Depending on what kind of calculator you have, it says under the PRB menu in your calculator. Now, if you have a scientific calculator, I think it actually is like a there is like a PRB button. Okay, if you have a graphing calculator, now if you have a graphing calculator, if you have a scientific calculator, there should be a button that says like PRB on there, and you should hit, right? Okay, you should be able to hit it, and then you should arrow over. I don't remember where like the exclamation point for factorial actually is, like the first or the second one. It might be the third one. But you just basically type in your number and then hit the PRB button and then go over to factorial and go from there. If you have a graphing calculator, so like it's 10 factorial, then all I'm going to do is I'm going to hit 10, I'm going to hit math, and then I'm going to need to go over to where it says prob for probability. And I will go over, and then there should be an exclamation point. It's probably the fourth part, okay, or the fourth number. You can hit 4, or you can arrow down and have 10 factorial and hit enter, and you can get 3,628,800. This saves you from going 10 times 9, times 8, times 7, times 6, times 5, times 4, times 3, times 2, and times 1. You're going to get the same value as long as you type everything in there, right? But you don't want to have to type in 10 different values and hit the multiplication sign 9 different times whenever you can do this so much easier. Yeah.
Can you do that one more time?
Yep. So if we just do the 4, so if I hit 4, right, the one above, I'm going to go math. I'm going to arrow over to probability, or PROB, and then I'm going to go down to 4, and I'm going to hit enter. And then I'm going to hit it again. Okay? Two others, notice that if I have 1 factorial, I'm going to start at 1, and I'm going to get, even if all you just go back to, if I hit 1 factorial, I'm going to start at 1, and I'm going to end at 1, and I'm going to have 1. Whereas with 0, what do you think is going to happen? What do you think my answer of 0 factorial is? 1? Did you already cheat and do it?
Yeah.
Oh, okay. At least you're honest. Okay? Because if you're starting at 0, all that's meaning is there's still one possibility. Okay? The only possibility is 0, but there's one possibility. Okay? 0 is that possibility. Okay? You're not thinking about taking 0. All we're doing is basically saying we're just counting it down. It's kind of like the 5 scholarship problem. There's 5, 4, 3, 2, 1, and then we go through it. Okay? It's really just counting it down as far as the number of times that can happen. So then here on 4 it says standard configuration for a New York license plate is 3 digits followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? So 3 digits, 3 letters. What's going to happen if it's just standard where everything can be repeated? What's the order? Like, how many digits can I have for the first 3 spots? Like, I have 1, 2, 3. Everything there has to be a number, whereas on the back end, everything has to be a letter. So what are my options for the first 3 blanks? 10 every time, right? So 10 times 10 times 10. What about for the back 3 spots? How many letters are there in the alphabet? 26. Very good. So I'm going to take 10 times itself 3 times. I'm going to take 26 times itself 3 times and get 1, 7, 5. So about 17,576,000.
Whoa, what? How did I get that?
Okay, that's a lot of cars. Now, the next stipulation then says how many different license plates are possible if digits and letters cannot be repeated. So, if digits and letters cannot be repeated, then as far as the first 3 spots of my license plate, it doesn't say anything as far as what can't be the first spot, but it does say that things can't be repeated. So then, whenever I do this, how are my first red blanks going to count down? 10, 9, and 8, right? And then for the next 3, or the last 3 blanks, it's going to go 26, 25, and 24. So again, like we talked about earlier, whenever we have our values, just by adding a stipulation, we went from about 17 million to down to 11,232,000. Anytime you add stipulations to a scenario, it's most likely, or it should, lessen that value. Okay? If you have an open run of whatever you can do, that number should be the largest number you deal with. But it's whenever you put stipulations on things that things are going to change. All right, last thing deals with permutations. Okay? Permutations basically are ordering of objects. Okay? Placing a certain number of objects in a certain number of positions. The notation, like it says here, as far as N, the P meaning permutations, and then R. Okay? N is the number of total people that you're dealing with. The R is the number of positions that you want to basically fill out. So it says how many ways can you place 5 students in 3 different chairs? Okay? Obviously, a person can't sit in multiple chairs. Okay? But if one person moves from one chair to the other, it doesn't say they just have to be in a chair, they have to be in a certain chair. Okay? Or like it says on example 5, 8 people running a race. We just had the track meet last Friday. Right? 8 people in a lane. How many different ways can you finish first through third? So whenever we go about that, so if there's 5 different students, 3 different chairs, how many different people can sit in the first chair? 5. What about the second chair? 4. And then what about the third chair? 3 different people. 2 people are left out. 2 people don't get a chair. Okay, if we're playing musical chairs. So 5, 4, and 3. Oop. So 60 different ways that we can rearrange this. That meaning one person has all the options as far as any chair. Same way, 8 different people, first through third, how many different ways can this thing finish? If we have 3 places, how many different people can win the race? 8 people, right? So if there's 8 people that can win, how many people can finish second? 7, and then 6. So 8, 7, and 6. They ran the 400-meter dash the other night. All lanes were full. There were 336 different ways that race could end. like on 6, how would I set up 6? Like how many blanks am I had 3 blanks in each one. How many blanks am I going to have on 6? 9. Why? Why 9? There are 9 spots, right? So I would have 9 spots and I would just go down from there. We're at 7, 8, and 9. Whatever number that I start with is the total number of people. Okay? So as far as lineup options, I would just go 17, 16, 15, 14 options, 13, 12, 11, 10, and 9. Okay? And multiply that all out to go from there. Last one is what's called a distinguishable permutation. Okay, you have n number of objects where one object is repeated q number of times. So like if I have the word basketball, so it says how many distinguishable permutations of the letters in basketball are there? Are you going to know the difference if I have this B and that B switched? No. What about if I have this A and that A switched? No. Okay? Or the L's or things like that. Okay, so whenever we talk about a distinguishable permutation, we have so many number of spots, but in certain cases, there are certain values that don't really matter. Okay, because it's not going to know, you're not going to know any different if I have a certain B or an A or an L. You're going to know if, obviously, the S and the K are in a different order. But you're not going to know if you have different values in different spots in terms of something that's the same. Okay? So